Okay, so the second topic we're going to take a look at this week ties into what we've been talking about with polynomials and talking about even degree and odd degree polynomials. One of the tasks you looked at talked about even function versus an odd function. That's a little bit different, but we're going to talk about zeros today, which are x-intercepts. So you've been working with these before and you were factoring last week. When you find the factors, that's helpful because then we can find the x-intercepts or the zeros or the roots of the function a lot faster. So for example, it says that a polynomial function of degree n can have at most n real roots. So if you have a cubic function, you should expect 3 zeros, right? We talked about that with the fundamental theorem of algebra. Okay, the most it can have is 3. It can't have more than 3. An even degree polynomial should have an even number of roots or zeros. Okay, odd degree should have an odd number of zeros. It also says that an even degree can have no zeros. When it's talking about zeros this way, it's talking about real zeros. So we know that a quadratic could, for example, have 2 imaginary zeros, okay, but that means no real solution, so that's where that's coming from. Okay, now for each one of these that we see on the examples here, and again you can print these notes out if you would like, we're just going to go through and graph these using the calculator or Desmos. So I have my calculator set up and ready to go. We are going to first of all graph x cubed plus x squared minus 2x. So let's switch over to that screen. I'm going to go to y equals. I'm going to clear out what is there. And I am going to graph, what did I just say? X cubed, x raised to the third, arrow out, plus x squared minus 2x. Okay, and we already, from the previous notes, have this so it's on Zoom standard, so I can just go ahead and hit graph. I've got a nice little cubic function there. What's nice about this is I can trace. It looks like 0, 0 is one of my roots. I'm also going to trace at -2 because it looks like that's one of my roots, or zeros, and it is, and it also looks like 1 is as well. Awesome. So I've got -2, 0, and 1. So I'm just going to quickly place -2, 0, and 1 on my function. Then if you really wanted to, you could go back to the graph, right, and we could trace at -1, for example. I could get a point that happens at 2, so I could graph that, and I can graph any other in-between points and just make my rough sketch of this graph. That's a super rough sketch, but you get the idea. Same thing for the next one. Go ahead and pause the video. Let's get that plugged in the calculator, and let's check our zeros. I'm going to just type up here what our zeros are in the meantime. Got -2, 0, and 1. I've got my next graph here. It looks like if I trace, my zeros are at -1. Let's just double check. Okay, sorry about that delay. Little Munchkin needed some help. Okay, so we've got -1 as a 0. It looks like 1 is also a 0. Yep, and then it also looks like 3. Okay, so we're going to go mark those, -1, 1, and 3. -1, 1, and 3. And then you can trace and get some other values as well. I could trace at 2. 2, 3 is a point. I'm going to look at 0. 0, 3 is a point. Okay, that looks cool. 0, 3, 2, 3. So again, I can make a really rough sketch. I'd probably like to get a few more points, but for the sake of time, I think that can give us a pretty good idea of what's going on. So we graphed the points. That's my very rough sketch, okay? Don't judge me. This is hard to write with. So we've got x equals -1, 1, and 3. Okay, those are my zeros. Okay, so now we want to try to think about how does that tie into factors, because that's what you were doing last week, and it wasn't just for nothing or just to do some review, which hopefully some of it was review, but we got into difference of cubes, and that was a little bit new, but factored form here. So first thing I want to look for is a GCF. It looks like my GCF here would be x. Okay, then I would have x squared minus 2x, and then minus 15. The next thing I'd be looking for are factors of negative 15 that add to give me negative 2. Okay, and I believe that those would be what? Negative 5 and 3. Okay, so those are factored form, and I'm trying to write as quick as I can on here, but again, this is not the easiest to do, so sorry about the not very prettiness of my writing. But we've got x times x minus 5 times x plus 3. Those are the factors. So how do I get the zeros from those? Well, remember, we set each part equal to 0. So I would say x equals 0. Okay, and then the next factor I set equal to 0 is x minus 5. If I set this part equal to 0 and solve for x, I should get a positive 5. Okay, and then the next part I'm going to set equal to 0 is x plus 3. If I set that equal to 0 and I solve for x, I should get x equals negative 3. Okay, so the zeros of this function would be at 0, 5, and negative 3. So if you put that together with what you did last week, all those factored forms, you're actually finding your x-intercepts, which is pretty darn cool. Okay, so for this next one, I already wrote this in factored form for the most part, but we're going to switch it up because these two factors are the same. So we would actually change factored form to x times x minus 3 quantity squared. Okay, the reason that this is significant is because that squared, that should be a parenthesis, that squared tells us how many times this factor shows up. You can also kind of see it here. X plus 3 shows up 1, 2 times. But on the graph, we are only going to see that once. But this is where multiplicity comes in. It talks about the number of times it occurs, or I like to think of it as the number of times that a factor shows up. So if this factor shows up twice, we would say that the 0 at 3, because when I set x minus 3 equal to 0, I get 3, that shows up twice. So I'd say the multiplicity is 2. X equals 0, that first factor shows up one time, okay? And then again, looking at the second factor, I can see that it shows up twice with the exponent, so it has a multiplicity of 2. What is pretty cool about these is that multiplicity really depends on what's going on with the graph. Okay, so if I have 0 as an x-intercept and I also have 3 as an x-intercept, if the multiplicity is odd, then it's going to pass through that 0. If it's even, it's going to be a turning point at that 0. So my guess when I sketch this graph is it's going to look something like this because it's a cubic function. So it's going to look something kind of like this. I don't know exactly where my maximum occurs, so that could vary a little bit, but if you pause and you plug this in to your graphing calculator or Desmos, I hope you see that we have a 0 at 0 and also at 3, and that 3 has a turning point. So go ahead and check me. Okay, so to finish off this video, we want to kind of go through that idea a little bit. It seems a little bit weird at first, but once we practice it a few times, I think you'll kind of understand what's going on. So if I take this factor right here, this x plus 7, and I set it equal to 0, remember that's our process for finding the zeros or the roots or the solutions or the x-intercepts, whatever you want to call them. Okay, remember I'm setting each factor equal to 0. So that first one, the 0, is negative 7. And then we see that it shows up twice, so it's a multiplicity of 2, which means in the graph it's going to end up being a turning point. Okay, for the next one, if I set 2x plus 1 equal to 0 and I solve for x, I would first subtract the 1, then divide by 2. So that 0 is negative 1/2. It only shows up one time. Okay, so its multiplicity is 1, which is odd, so that means it's going to pass through that 0. It's just going to be normal at that 0. Okay, the next factor that we see is x minus 4. Set that equal to 0. Solve for x, I get 4. Its multiplicity is 3. It shows up 3 times, which is odd, so it's just going to pass through. So again, pause the video. You can plug this into Desmos or graphing calculator and check and make sure that you're seeing a turning point at -7, and then at -1 and 4 it should pass through. So that's pretty cool. All right, so if we go into this next one, number 7 isn't as nice because it's not given in factored form. So first thing we want to do is go through your steps from last week. Factor out a GCF, and then we want to see how many terms we have and what strategies can work. So GCF should be x squared. I factor that out. Then I'm looking for factors of -8 that add to give me -2 because this is a quadratic. I find that that's -4 and 2. So pause for a minute. What would those zeros be? Well, my first 0 should be 1 because if I set x squared equal to 0, I get 0. I'm sorry, that first 0 should be 0, not 1. So we are going to get 0, and it shows up twice, so it's going to be a turning point. So I put that in here as TP, turning point. Okay. The next two factors only show up once, and these give us zeros at 4 and -2. So I didn't write anything in there for the effect because that would be a normal 0 for us. Okay. The next question. I love questions like this. It kind of takes you a little bit further. So now I'm giving you kind of the opposite. If I tell you where the zeros are, can you find where the factors should be? Okay. So if I know there's a 0 at -6, what factor would I need so that when I set the factor equal to 0 and solve for x, I get -6? We've talked about this before, so this should be a factor of x plus 6. Now it does tell us that there's a multiplicity of 2, so I'm going to put that 2 right there. So I have x plus 6 quantity squared. Now the next factor we need to think about is a 0 at +2 with only multiplicity of 1. So if I have a +2 when I solve for x, that means I'm going to have x minus 2 is what's set equal to 0. Okay, and then it says write the polynomial in standard form that could represent this function. So what we're going to do now is distribute, FOIL distribute. So I'm going to give you a couple minutes to figure that out. I'm going to pause the video and I will show my answer. Okay, so you can check out, I first took x plus 6 times x plus 6 and I got this, times x minus 2, and here's what I got in standard form. Okay, so that's what your assignment is about today, and I think that might be it. Characteristics of a polynomial, this is something we will go over next week a little bit more, but I want you to start thinking about, okay, if I gave you a function, could you find the turning points? What would the parent function be? What would the end behavior be? Where's the increasing intervals, the decreasing intervals? What's the domain and the range? What are the zeros? So that would be something that by the end of this week I would want you to be able to do. So I will post this on Google Classroom as well. Have a good week, guys. Let me know how I can help.